Hello everyone, I'm Huda Rumuh from Iraq, Babel, University of Babylon College of Engineering, Electrical Engineering. I'm master student, visible light communication based on chaos encryption scheme. Presentation outline, introduction, design and implementation, results and conclusion. First, many factors that must be taken consider to communication system, but two of most important parameters are privacy and efficient transmission data. Secure communication system based on chaotic signal using visible light was designed and simulated to achieve two factors, two important parameters, privacy and efficiency. Visible light communication is a part of optical wireless communication that's used in recent years using radio spectrum to transmit data wirelessly. Visible light communication frequency range 430 terahertz to 790 terahertz. This is show the frequency and the wavelength of visible light communication range. Visible light spectrum via illumination of light-emitting diode. The effectiveness of visible light communication is investigated over a range of transmission distance and different chaotic signal with input frequency 500 terahertz and 10 gigabit per second data rate. For data security, encryption and decryption system was built using double delay feedback. The simulation results provide efficiency of the encryption system in terms of complexity of signal transmission side and return to the signal in the receiving side after subtracting the chaotic signal. The semiconductor laser chaos generation now being utilized the mean of multi-level data. In order to address this concern reading data security, the incoming signal was concluded prior to the optical chaotic signal transmitted via optical fiber medium by our suggestion method, which makes use of double delay feedback technique to create optical chaotic signal. Design and implementation. In figure show the input signal is fed and pre-processed into Mazen rectifier. Our suggestion plan for the security of the communication system through optical chaotic. The Mazen rectifier modulates the input signal using the light beam produced by the CW laser to transmit signal with less attenuation losses. The CW laser frequency is set to 500 terahertz to enable the modulation of the input signal with laser light. The extension ratio of the Mazen defined as the ratio of two levels of optical power to the digital signal produced by the laser was set 50-50. The chaotic semiconductor laser optical output was then provided the Mazen to the Mazen where it was combined with this waveform. The semiconductor laser operating frequency was maintained at approximately 500 terahertz, allowing to have forms to the light produced by the input waveform modulating by the CW laser the chaotic produced by the semiconductor over signal single mode fiber. The optical output is sent filter to the input signal has been made safe in the optical field. On the receiving side, a signal was removed here. Was removed from comparable chaos that was produced using double delay feedback technique before the photodiode pick up the signal or optical receiver. After that further reduce the effect of the noise and restore the input signal. Low pass filter was used that used the bit error rate. Generating chaotic signal. This is the figure show how to generate chaotic signal. PD is a photo detector with a specific effect amplifier, ALDI continuous laser light, MZM Mazender is the drive by frequency RF divider, OC1 and OC2 couplers, OC2 light divide to the MZM Mazender output into finally RF and BT driver lead to the MZM optoelectric reflection feedback from the EDFA. The MZM optical feedback, the laser output chaotic and the power P out takes to the MZM. Within this scope of this study, to an investigation of the chaotic laser efficiency at cheap cost, it has seen how to well semiconductor laser function with double delay feedback. In this course experimental study conducted with the OptiSystem semiconductor, the characteristics of the laser have also been established. The original system was built by initially feeding the chaotic laser output back into the Mazender MZM. The study of the system include both dynamic gain efficient modification and addition of the second time delay. The feedback duration and feedback intensity of the agreement chaotic system are investigated over a wide range of input bias current frequency and modulation feedback and modulation peak current condition. The optoelectronic oscillator chaotic laser output is more complex and exhibits lower delay characteristic according to the manufacturer diagram. Simulated diagram of visible light communication. This is the simulation diagram for visible light communication using chaotic system. This is show the subsystem of that chaotic signal was generated here and here that we use 500 terahertz. Simulated diagram of chaotic system subsystem that we use to generate chaotic signal. We use here bias current 70 milliampere and modulation peak current 40 milliampere. Results. This table show the results. Channel length 100 meter to 2 kilometer and use the result of 4 kilometer bit error rate and Q factor. This is show when 100 meter. This is the result 6.6 for 10 minus 38 and 19.7 for this figure show the input signal, and this is the chaotic signal generated using double delay feedback with the bias current and modulation peak current. Input signal embedded with chaotic signal. When input is added, input signal is added to the chaotic signal. This is the result shown in figure. We suggested a method for the safe transmission of input signal that make use of light that is visible of the human eyes. Chaotic produced using a process called double delay feedback, which is parameter modified to get necessary bandwidth and amplitude. This when we using continuous wave. This is the result that I show it. The installation of security measure that the input signal was verified to analysis both of frequency and the temporal domain. According to the fading hour investigation, the Q factor receiving is dropped to 10.5 at fiber length 4 km and 19.74 on 1 meter. This is the result, and I get more results when I change bias current and modulation peak current. Thank you.